Standard form. Standard form is ax squared plus bx plus c. A, b, and c are just numbers. A quadratic is a function that has a degree of 2. First thing we do whenever we are trying to graph, I would start by the same way we started yesterday, which is just listing the a value, b value, and c value. If you want, you could fill this in with like a is a number, so is b, so is c. So I would write those out. So that way when you do your axis of symmetry or your y-intercept, you have it all right there. Then, just like yesterday, after we get what we can, we're going to do the axis of symmetry. Plug that x value in to get the y, and then this point, xy, is the vertex. So in order to graph a parabola, the bare minimum would be the vertex and one other point. I'm going to expect the vertex and probably 4 other points, but the axis of symmetry is going to be really helpful for doing those points quickly. So other points. So you have the vertex, which is the base of it. We need other points, so we're going to do that by creating a table. I know that we did this for exponentials. Do you remember making a table for exponentials? Perhaps? Okay. So you can do the same thing for linears. Any single function that you have, you can always take your input values, your x's, and plug them in to get your output values, and that'll give you points. So this always works for any function. So that's what we're going to do for quadratics, and we'll get in a good habit of it. We're going to make sure and plot points from the vertex. So once we actually have our x and y values, we're going to do it from the vertex, both left and right. And then the table will be symmetrical around the vertex. I would say same thing for the graph. The axis of symmetry is just like it sounds. It makes things symmetrical. Let's start by writing out A, B, and C. Please tell the person next to you, or if you don't have someone next to you, turn to the person closest to you and tell them, please, what's A, B, and C? Hey, Cora, what are A, B, and C?
A is -1, B is 2, and C is 3.
Indeed. Okay, now we know that, we are going to, let's see what it says. Find. Okay, we're going to find the axis of symmetry next, which is our x value of our vertex is also helpful when we graph. So x equals -b over 2a. We already know what b and a are. So you can go ahead and solve this out. I'm going to do the same thing on the board. -2 over 2 times -1. So -2 over -2, which is 1. So for our axis of symmetry, what should I write, Bella? What do I say? X equals 1, thank you. It's an equation of a vertical line, remember? So we know now that our vertex is at 1, comma, something. In order to have a graph, we have to have a vertex. So do the same thing we did yesterday. Here's the deal. We can, let's go ahead and get the vertex first, and then we'll make the table. That sounds good. So y is equal to x is 1. 1 squared, make sure your negative sign goes outside, because it's not -x squared. It's x squared times -1. Be careful, please. Plus 2 times 1 plus 3. So that would be -1 plus 2 plus 3. -1 plus 5 is 4. So my y value for my vertex is 4. Make a table. You can make a table, a vertical table or horizontal table. It does not matter. I'll do probably both ways today. So I'm going to make a table this way. And this will be x, and I'm going to call y, I'll call it y for this one, but notice that it says f of x, which remember just means y. We want the parabola to be symmetrical around the vertex. I really only need 1, 2, 3, 4, 5, so let's get rid of this one. Where do you think I should put that vertex? Tell the person closest to you, where do you think you should put it? Where should I put it, guys? The middle. It's the vertex, so it's going to be the middle of the graph. So the x value is 1 and the y value is 4. Put it in the middle. Now, here's the cool part about this. I really only have to do 2 more numbers because the other numbers will be symmetrical around the vertex. So I'm going to plug in 2 and 3, I think. Or actually, 0 sounds easier. 0 and 3. And I'll show you how this works. So let's write it out to the side here. Let's plug in 0 into our function. I'll do it in black. The y value is negative 0 squared plus 2 times 0 plus 3. 0 squared 0 times negative 1 is still 0. 2 times 0 is 0 plus 3. So what's my y value? 3. Okay, so then right here in my table I put 0, 3. I'm going to do... Oh, and what do you guys notice about that? Yeah, what you see right here. So if you have a y-intercept and it fits in your table, you could just put it in there and take a shortcut. Okay, and let's do 3. So I'm running out of room. I'm gonna do it below. Y is equal to negative 3 squared plus 2 times 3 plus 3. Remember, that means 3 squared first, order of operations. 3 squared is 9, so that's negative 9 plus 6 plus 3, so it's 0. So I'm going to want these to be, I probably should have filled this in first, negative 1, 2, and 3. So I'm just doing the numbers that surround it. We just did 3, which is 0. I know this seems kind of weird, but because I want you to see it visually, we're going to graph those 3 points right now. So we're going to graph, normally I would not recommend this, but we're going to do it right now because it'll still work out. We're graphing these 3 points. 1, 2, 3. Okay, so go to your graph, and we're going to graph 1, 4 is our vertex. Oops. Next one is 0, 3. This should be opening down because it's got a negative a value. And 3, 0. Okay. It does not look like a parabola right now, maybe like a little bit. Here's the nice part about the axis of symmetry. You can either fill it in on the table or you can graph it and then fill it in. This is my axis of symmetry, is that line that goes through x equals 1. If that's hard for you to see, I'll try to make it better. And you do not need to graph the axis of symmetry whenever you graph quadratics, but it's helpful. If I have this point on the left, 0, 3, then I have to have a point that is directly across from it. So we have to have a point at 2, 3. So on our table, you get the same thing if you solve it out. I'm going to put a 3 where the 2 is. Same thing, I have a point at 3, 0. Could someone please tell me where would my other point have to be? Luke?
Negative 2, 0.
I'm
negative what?
Negative 1,
Negative
I think.
1.
Yeah, there you go. Negative 1, 0. Okay, so you see the graph now. It's symmetrical around that. We would go ahead and make it a parabola, which that was pretty bad. It should really make sure I go through the points. Make sure you got arrows signaling that, hey, it goes to a negative infinity forever and ever. And now I want you to look at, you're going to look at your table. Tell the person closest to you, what do you notice about your table now? What do we see? Ethan, what do you notice?
It goes 0, 3, 4, 3, 0, so the Y's are like...
They're repeated because it's symmetrical. So here's my vertex, and then around that, my Y values are gonna go together. I don't know a good way to say that. So whenever you're making your table, since we found 0, 3, and 3, 0, I would have to know the point 2 away from the vertex would also have to be 0, and the one that's 1 away would also have to be 3. So that's a shortcut to filling in your table quickly. Okay, let's fill in these last few things about the key features, and then you're going to do the next one on your own. This is the only example I'm going through. Okay. Safik, which way does this parabola open?
It opens up.
Look at it again.
Oh, that one?
Yeah, this one. Yeah, down. Because it's negative, and you can fill in all this stuff before or after. It doesn't really bother me. It might be helpful to do it before. So it has a maximum. What is our domain, guys? Bingo. And our range to 4. Negative infinity less than or equal to 4. And my y-intercept, that's something you're going to have to look at the graph for, or look at your table for, or look at the c-value for. My c-value is 3. It should match everything else as well. It does. So 0, 3.